Hello guys, in this video we look into the cooling curve. Okay, before this we already looked at the heating curve. Okay, heating curve. For cooling curve, okay, how to identify the cooling curve. So first you look into your axis. Okay, axis. Here we have time. Look at the time. So what will happen to the temperature once the time is increasing? Let's say from 0 to 20 seconds. Okay. So once the time is increased, so for cooling curve, the curve should move downward, or the temperature should be decreasing. Okay, that is the difference between cooling curve and heating curve. Okay, if we have heating curve, so heating curve, time increase, let's say 0 to 20 seconds, but the temperature will increase. Okay, temperature will increase. So this is heating. For cooling, temperature will decrease. Okay, so that is the difference between heating curve and cooling curve. So now let's look into our cooling curve. So given here is the cooling curve for the same material, naphthalene. Okay, naphthalene. Why can I say so? Because as you can see there, the freezing point, okay, the freezing point where the substance start to become solid, and the condensation point, condensation point is where the substance start to start to change from gas to liquid. So the condensation for point 218, condensation point is equals to the value of the what term that we use before. Okay, condensation point, the boiling point. Okay, the boiling point. So it should be the same. So here we have 218. So same with the amount that already given in our first video, 218. So it belong to naphthalene. And then we have 80 degrees Celsius. Okay, 80 degrees Celsius. So 80 degree is the freezing point. Here they use freezing point. Freezing point where the substance start to change from liquid to solid, and it should be equals to the what term that we used before. Okay, freezing from solid to liquid, it is the melting point. Okay, it is the melting point. Okay, freezing equals to melting point, and then condensation point is equals to the boiling point. And normally we just use these two terms, either boiling or melting point. Okay, so what we have here is the freezing point or the boiling point of the naphthalene, and then we have this is boiling freezing point. This is the condensation point or the boiling point of naphthalene, which is equals to 218 degrees Celsius. Okay, and then the curve. Okay, the curve will looks like this. Temperature decrease, flat, and then temperature decrease, and then flat, and then keep decreasing. Okay, so here we have point A, point B, point C, point D, and point E. So here is D, E, C, and B. Okay, again from B to C, it should be constant, which is equals to 218 degrees Celsius. And from D to E, it should be constant, which is equals to 80 degree Celsius. And of course, time will increase. Okay, time will increase from here 0 to t. So what are the information that we can get from this cooling curve? The first one you can get is the freezing point. Sorry, here is the freezing point, or you can use as the melting point. Let's say the question asks what is the melting point of this substance. So 80 degrees Celsius, since it is the freezing point, so it is also the melting point. And then what is the boiling point of this substance? Since 218 is the condensation point, that's mean from gas to liquid. So it is also can be said as the boiling point from liquid to gas. So two important information that you can get from this curve. And then what about the phase? Okay, at AB, from this point A to B. So what do we have here? Okay, the temperature is just before the boiling point. Okay, so AB, all of the substance are in the gas phase. Okay, gas phase. And then it will lose energy. Let's say it will lose energy until the temperature decreasing until point B. Once the temperature reach point B, what will happen to the substance? Okay, let's say this is our substance, gas. Okay, first gas. So first we have gas. So from gas, what will happen? At point B, so B is a condensation point. That's mean at point B, some of the gases will start to change its phase from gas to liquid. Okay, liquid. But still, some of them are in the gas phase. Okay, here from B to C, we have liquid and gas. So temperature will keep constant. Why it is kept constant? Because all of the heat being used to overcome the force of attraction between atoms and molecules until it reach time C. Okay, after a few times at point C. Okay, at point C, remember the temperature is the same. So at point C, after a few times, all of the all of the gases here already change into liquid. Okay, liquid. So at point C, we can see that all of the substance already change into a liquid. So there is no gas anymore inside this substance. And then what happened if they kept losing energy? Okay, if they kept releasing energy, so the temperature will decrease until they reach the temperature 80 degrees Celsius, where 80 degrees Celsius is the melting point, or is the freezing point, where the substance start to freeze, to solidify, to become solid. Okay, here some of the liquid will change from liquid to solid, and still there are some liquid. Okay, it is not complete yet. The process not complete yet from liquid to solid. And then the temperature will keep constant until at certain time. Okay, let's say this is TE. Okay, until a certain time, what will happen? Then all of those liquid can be said had been changed into solid. So beyond E, what we have here is just solid. Okay, so that is all about the cooling curve, about the information that we can get from the cooling curve. Okay, as you can see here, flat line, two flat line, just like what we have in heating curve. Okay, whenever there is flat line or horizontal line, normally we will have two kind of phase. Okay, either liquid and gas or solid and liquid. Whenever there is change in temperature, either in cooling or heating curve, either the temperature is increasing or decreasing, normally we just have only one phase, either gas, liquid, or solid. Of course, you can read all of the theory, okay, kinetic theory being explained here. So let's go through first at A, B, C, D, and E, F. Okay, A, B, C, D, and E, F, where the temperature is changing or decreasing. So heat release. So here, heat release. Heat release. Here also heat release. Here also heat release to the surrounding, and kinetic energy of the molecules decrease. So Ke decrease. Here Ke decrease, and here Ke decrease. That means the motion of the particles of the atoms or molecules in the substance will become slower, weaker. Okay, because they lose energy, and resulting in a fall in temperature. So at B, C, D, and E, okay, at B, C, and D, E, okay, these two flat line, B, C, D, E, so the phase change occur. Okay, B, C, D, E, phase of change start to occur. The latent heat here is released. Okay, let's write it in the color. Okay, from B to C, latent heat release. And from D to E, latent heat release to the surrounding as the molecules become more closely packed. And then what will happen? So the atoms or molecules don't have enough energy to overcome their force of attraction between them. So the energy released does not decrease the kinetic energy. Here, kinetic energy, there is no change in kinetic energy. So the temperature remain constant. That's why we have a flat line. So I think that's all for cooling curve. And thank you.